Hi, I am Lopa Mudrashen. Welcome back to my channel Electronic Science Tutorial. I will start a new lecture series on NTA UGC NET and West Bengal SET exam for Electronic Science subject. Those who are not follow my channel, please follow my channel. If you like my channel, then please like, share and subscribe my channel. So let's start our class. In previous class, we talked about what is Zener diode and how Zener diode works in reverse bias condition. What is the difference between Zener breakdown and avalanche breakdown, and what is the circuit symbol of Zener diode. Today we talk about one new topic of Zener diode, that is the application of Zener diode. How Zener diode work as a voltage regulator. Okay, so let's start our class. So our discussion topic is Zener diode as a load regulator. How Zener diode work as a voltage regulator or as a load regulator. Today I will discuss about this topic. Okay, so what is the meaning of regulation? Why regulation or regulator? Why Zener diode work as a regulator? Because the constancy of the voltage across the Zener diode in the breakdown region makes it a useful voltage regulating device. So this is the circuit arrangement of a Zener diode as a voltage regulator. Okay, so by which we can easily regulate the voltage. So this is the supply voltage. This side is positive side and this side is negative side. This resistance is called limiting resistance. This is the Zener diode. So this circuit symbol we already known, that is this is the circuit symbol of Zener diode. This side is P side and this side is N side. So this N side is connected with the positive terminal of the power supply and the P side is connected with the negative terminal of the power supply. So what does it mean? It means that the Zener diode is in reverse bias condition, and this is the load resistance which is defined by RL, and this is the regulated voltage. This is defined by VL. When we applied a supply voltage here, a current will flow through the circuit. So limiting resistance limit the current, and in this node the current will be branching, and through the Zener diode IZ current, that means Zener current, will flow, and through the load resistance load current IL will be flow. So this is the circuit arrangement of a load regulator. Okay, so now two things here we connect, that is 1 voltmeter I will connect here. It is called as V3. This side is positive side and this side is negative side, and 1 voltmeter I will connect here, and this voltage or this voltmeter is called V2 voltmeter. This side is positive side and this side is negative side. Okay, so this is 1 voltmeter and this V2 is 1 voltmeter. Okay, so these 2 voltmeter I will connect in this circuit arrangement extra, because this V3 voltage will measure the power supply voltage and this V2 voltage will measure the Zener voltage, and so here we connect this 2 voltmeter extra. Okay, so this is the all over circuit arrangement. So this is the load regulation graph. We discuss about this graph in later section. First of all, here we saw this side, this X side is denoted by IL or load current, and this Y side is denoted by load voltage or regulated voltage, that is VL, and this voltage is called no load voltage, and this voltage is called full load voltage, VFL and VNL. Okay, and this current is called no load current. I will later discuss this graph. So the variation of the output load voltage, that is VL, as a function of the load current for a given input voltage, which I will given here, is known as load regulation. Okay, that means the variation of the output load voltage VL as a function of the load current IL for a given input voltage, which I will supply here, is known as load regulation. Okay, so the degree of stabilization is usually expressed in terms of percentage regulation. So the variation of the output load voltage VL as a function of the load current IL for a given input voltage is known as load regulation. And by calculating, how it calculate, that is SL equal to V no load voltage minus V full load voltage divided by V full load voltage into 100%. So this is the percentage of regulation. Okay. Where VNL, output voltage with no load, that means load current equal to 0, and RL, that means load resistance, that is equal to infinity. Okay, so VNL means, or no load voltage means, IL equal to 0 and RL equal to infinite resistance, and VFL is the output voltage at a particular rated load current. Okay, so this is the load regulation of a Zener diode. So how this load regulation will be performed by Zener diode? First of all, we keep the input voltage Vs fixed at a value which is higher than Vz. Usually this value is 1.5 Vz less than equal to V less than equal to 2Vz. Okay. So in this range, we can fix the input voltage. Okay. Which is much higher than the value of Vz. Right. In this condition, first of all, disconnect RL. That means load resistance. This makes IL equal to 0. Okay. Note down the output voltage from the voltmeter V2. Okay. So this voltage is called VNL or V no load voltage. So first point is keeping the supply voltage within this range. Okay. We should remember that the supply voltage value much higher than the Vz value. That means the Zener breakdown voltage value. And in this condition, if we disconnect the RL or load resistance, we know we get IL equal to 0 because the circuit is now open circuit. Okay. Because RL is the infinite resistance. In this condition, we note down the V2 voltmeter value, and this voltage is no load voltage or VNL. Right. Now connect the RL with a suitable high load resistance such that you can fix it as 10 milliampere flow. Note this value of load current. If we connect, just a minute, if we connect one current meter here, okay, if we connect one current meter here, this side is positive side and this side is negative side, and if we insert a higher value of load resistance such that this current will be 10 milliampere. Okay, so through this circuit 10 milliampere current will now flow. In this condition, we note down the voltage from V2. In this way, we can increase the load current, like next reading is 10 milliampere and we note down the voltage from the V2 voltmeter. Third reading is 25 milliampere, next 30 milliampere, and in every step or each and every step the voltmeter V2 value has to be noted. Okay. So if we increase the load current in small steps like 5 milliampere graph, and each step we note down the reading from current meter and from V2 voltmeter. Okay. And check the constancy of the input at every step. Okay. If we adjust this voltage, we can adjust it. Right. If we does not need any adjustments, keep it fixed. Okay. So this is the load regulation practical. In this way, we can work as a Zener diode as a load regulator. To get the load regulation curve, plot IL in milliampere range along x-axis and corresponding VL in V voltage along y-axis. The nature of the curve will be this type. This is the no load voltage when IL equal to 0 and RL equal to infinite. Okay, and if we increase the current, we saw this type of nature, and this is the full load voltage. When we connect the RL with a high load resistance, this is the full load voltage, and in this situation we get the no load current. So this is the graph of load regulation for Zener diode, and this is the practical examination of Zener diode as a load regulator. And from this graph we can easily define the percentage regulation, that is VNL minus VFL divided by VFL into 100. That means the percentage of regulation we can easily calculate from this equation. Okay. Here we discuss how can we calculate the limiting resistance value, that is the RS value. Okay. So how we can calculate? First of all, we consider one example that we consider here, that is the Zener voltage is 5.6 volt and the power, maximum power across the Zener diode, that is 1/4 watt, and the minimum voltage, maximum VI max, that is the 10 volt. So what is the power? Power equal to V into I. So IZM equal to power divided by voltage. That means if we calculate, if we put the value, that is 1/4 watt and Vz is 5.6, here we get, that is the IZM 44 milliampere. Okay. So the resistance value is Vi max minus Vz divided by Pz max into Vz. And if we put the value 10 minus 5.6 divided by 1/4 into 5.6, that is the 100 ohm. This is one example. We can easily calculate from this example. If we know the value of the Zener voltage, that is this is 5.6 volt or this is 4.7 volt, we can easily calculate the RS resistance in this way. Okay, this value is almost same. This value is Pz max is same, Vi max is same. So if we consider Vz equal to 4.7 volt, that means the Zener diode voltage is 4.7 voltage, then the resistance value is changed. But in this way we can calculate the limiting resistance value. In our discussion, we can consider here 5.6 volt, so the limiting resistance value is 100 ohm. When you practice this Zener diode as a load regulation, if we know the Zener diode voltage, then we can easily calculate the limiting resistance value. Okay, so this is the way out of calculating the limiting resistance, RS. Hope you understand the voltage regulator or the load regulation by using Zener diode. Thank you, friends. Thank you. With this, we have come to the end of our session. I hope you like this video. If you like my channel, please do like, share and subscribe my channel. फिर मिलते हैं एक नई वीडियो के साथ. Thank you.